Hello and welcome to the Barbaric channel. Today we'll build a fuzz face clone. Like we haven't done that before, actually. Uh, yeah, so we won't be doing that. What we're gonna do is we are going to design a PCB board for a fuzz face clone, and we're gonna complete it at a later stage. So before we've done this before. This fuzz is here, and I did a simple fuzz face clone, but recently I was looking at what I did before, and I did this for my son. This we're gonna call it Wilson Fuzz. Just every pedal has to have a name, and it would be lame to say fuzz face. But like we were playing with we were watching Castaway, and he liked the movie, so this is kind of a how it ended up. But like we're gonna build something like this. I wanted to do this as a PCB board design, and what we're gonna do is we're gonna do it in a KiCad, and then I'm going to order it through PCBWay. PCBWay, you can use any uh, fab house. I usually order from them. I use other fab houses, but this will work for any fab house, really. The reason why I chose PCBWay was they have a nice plugin, so it kind of makes things easier. So uh, why PCB and why Fuzzface and why like Fuzzface is pretty simple circuit, and this will help us go get into if you want to design your own PCB boards. This is not just for pedals. Pedals are very simple to build. At least the ones that we are going to cover now. You can go as complicated as you want, but this is, I think, good entry point to PCB design. And even if you don't want to if you want to just do any PCB design, this might be useful to you. So we're gonna use KiCad. Here it is. And I'll post all the links and all the documentation and everything that I cover here will be in the description. Also, I'll try to keep this short, but it's kind of it takes a while to create a PCB board, like it's something that is physical and you want to be careful with it. So I might take a bit of time, but there will be chapters underneath, so we can, you know, you can jump in it anytime you want. So no, KiCad, it's free, it's brilliant, great community, and they just released version 8. So we're gonna use version 8. It's slightly different from version 7, but only slightly. I strongly encourage you, if you use it, to donate. I normally donate every time I get the latest, version, like version 7, version 8. Um, you download it for covers all major operating systems. You download, double click, next, done. Here I have both KiCad 7 and KiCad 8. As I said, like it's really great. It has great community, and anything you want to ask, you can ask there. Okay, and you can pretty much find answer to anything, right? So that's that. Now, first phase, if you follow what I do, I usually go through the trouble of putting LT spice. I do this analysis, simulation, and then I do breadboarding, and then I assemble it, and I try it out. And in this case, with such a simple circuit, it's probably easier to do it on a proto board, and it's quite quicker. But we'll do it this way, and I'll follow the simplest schematic. I did some experimentation, and I did, here I tried loads of different things. Actually, here I tried BC549C, and this is what I'm going to use. I have drawer full of them, so I'm just going to use them. So we're going to follow this schematic here, and we're going to do the work. Now, as I said, I tried it before, but it's always a good idea to breadboard with components that you're going to use, okay? As you can see here, just in case, before I started this, I wanted to make sure that this BC549C sounded good, and it did. Now you can see here this this transistor here died on me unexpectedly. That was a bit of a head scratcher. I replaced it and it worked. So sometimes, you know, it's a good idea to do this regardless. But I don't like to skip steps, so that's what I usually do, you know. Before we plunge into this, I hate working from scratch. I usually either copy paste my previous project and then work with that, or I'm leaning towards templates. The reason for this is every fab house has its own set of capabilities, and what that is what is the number of layers, what is the materials, maximum dimensions, maximum tolerances, etc., etc. So if you look at PCB, you know, there's quite a lot there, you know. And why is this important? It's important because we are not doing something that's theoretical, you know, like this is physical thing, and it, as anything, it has its own limitations, and we need to work. Now we are doing a board that is, you know, it's a guitar pedal. It's not critical as much as we like to think about it, but it gives us great enjoyment. I hope we all agree to that. So, you know, we want to make it right. So this is good. So what I usually do is I start with, so I looked it up, and there is this design rule check. This is that you have all these rules, and then you draw your boards, and then how do you know this is all correct? So you have this design rule check, and this is great about KiCad. KiCad, it's super powerful, you know. So you go and you build your you draw your board, and then you run tests to check that everything is in compliance, you know, what with files that you're gonna do. And PCB, and you can read it up here a bit. PCB has here for KiCad and other CADs or EDA design software, if you want to be precise about it. I downloaded this one, and I did a bit of I changed it a bit to make it a template rather than, I didn't change much. I just added some kind of I'll show you that. But keep in mind that this is all statements are without guarantee, you know. Anyway, you're responsible for your own work. There are other templates. I use this template a bit in past, so you know, you can go and you see there's other Fabhouse templates. I used this one, you know, and you can see what comes in a normal template, you know. But that's it. So let me start with this real quick, and let's get that. Let's start. I'm just going to open KiCad 8 as any software on Windows. I use Windows. Don't hold it against me. Here, I'm going to start a new project from template. That's how I started. And here you can see KiCad comes with a bunch of templates. You know, you can do all sorts of things out of the box. I'm going to find my own, see this here, KiCad, and have these templates. I have this version 7, version 8. I just did a tiny fix. There was some change in version 8, and it messed up my drawings. So my logo. Ugh. But I'll put this up, and you can download this, and you can then use it if you want it. The thing is, you know, I made it out of that PCB downloaded template. As I said, I just cleaned it up a bit because I didn't need all the files. So we're gonna call this Wilson Fuzz, and this will create a new folder for the project there, and it will call it Wilson Fuzz. Ah, beautiful. It was an easy start. So here, this is your project view. There are other tools. I'm not going to cover everything. I'm going to go and do bare minimum that I can get away with, because this is going to be quite long. But here, things that came with this template is like this. I added this actually because Vanity is great. You add your own logo and your link, and this is your template. You can change it. Just double click, make the changes, off you go, and this is how my new sheet will look like. Okay, that's that. This is schematic. This is your PCB, and these are design rules. I'll come to that when we talk about creating a PCB. The first thing we want to do is create a schematic, right? So I just double click here. That's it. Beautiful. We already have something there. In my template, if you go to page settings, you can put all these various values here. So we're gonna go title, Wilson Fuzz, and I'm gonna leave it at that. And you can see it looks real professional. We are real professionals, right? So that's the first step, opening schematic. And what I'm going to do is I'm just gonna do where is this? Oh yeah. If you're at any point you're unsure what anything is, you can always go and look up. What I did was I just looked up here KiCad reference manual, and how do I go back? And here I found what each file is, and if you're ever wondering, this is why KiCad is great. It has great documentation, and you can find anything, and you can find anything you want, really. Oh yeah, what I want to say was we are going to do this, right? Let me go back to that previous. So I'm going to just, as I said, BC 549C instead of BC 109. I just prefer BC 549. It won't make any difference. But when we finish it, because it's only 3 pins, you can put any, if you wish, you can put any transistor there on the finished board, even if you use my version and put any transistor, just making sure that your pinout is correct. But if you want to, you can just, edit the board. Again, I'm gonna put up the whole project there so you can download it, do whatever you want with it. Okay. Okay, so I'm gonna put this on my other screen, and I'm just gonna draw this super quick, right? Okay, so this is blank canvas, and let's do a simple thing. We're gonna add first transistors, right? And I'm just gonna click here. This is to add your devices, and first time it runs, it's gonna be a bit slow it caches everything, and it will have a local cache of all your components that you're using. And you can see here, there's over 20,000 items there. So this is really, really powerful program, and it should have most of the things you will use. At some later stage, we're gonna cover how do you add things that don't exist here, but that's a bit later. So let's see. I usually just BC. You just search for it and you find it. Always check. Always check. Whether if in the end of the day, this is correct. I checked it, but when you're doing this, you're well kind of advised to check this. So You see here the cursor has this little plus button. That means it is still in mode of adding, so I can click again and add. And this is super slow, so I'm gonna press escape. But whenever I want to do something, I'm just gonna do. So let me add resistors. So I'll show you what I mean. Save resistor. I'm gonna use this one. So here, I just don't want to click every time, so I press escape, and you can highlight it here, right click, and copy paste, or you can do Control C, Control V, Control C, and Control V, 2, 3, 4, and I click every time. So Control V, click. How many do I need? 1, 2, 3, 4. Okay, I don't need one. This one. So to delete it, you press delete. It used to be D, now it's show data sheet, I think. I just hate delete because my keyboard has awkward delete. Anyway, I might change that. As I said, like it's very uh, uh, configurable. You can do whatever you want with this, so it's really good. But like we're okay. So I'm gonna zoom this in a bit. Right click, and you can move the sheet around. So I need 3 electrolytic capacitors. Okay. Capacitor. Okay, we need unpolarized one, and we need 3 polarized ones. Yeah, so it's here. Okay. There. So I'm gonna do that. Escape. Control C, Control V, I need 3, Control V, 3. Okay. What else do I need? I need 2 potentiometers. So and nice, it's here. So we're gonna have 2 of these. Control C, Control V, done. Okay, escape. So that's that. I'm just gonna try to keep the diagram as close to what I have here as possible. I mean, I'm gonna even give them the same designator numbers, and I'm gonna try to make it as close as possible to this. Okay. Let's wire this up. So this should be fairly straightforward. Like we have Q1 BC549. I'm gonna keep it here. And even though notice here the pinout is different, so it's 1, 2, 3, but here it's 1, 2, 3 this way. It's still the same schematic symbol, so you have collector, emitter here. It's correct. Let's wire it up. So I need C1 here, and I don't need to like I can rename them. Like I click C2 and press right click, and you can do edit properties, or you can just press E, or you can press E here, and you get all the details of that. So we'll cover that later. So I don't really need to. Actually, I don't have C1. This one is going to be my C1, right? C1. Okay. Oops. Click, move, rotate, transform selection, rotate, R. So I'm gonna press R from now on. Okay. So R, so it's here. Make sure it's correct. Oops. Click. See how it changes the cursor. Okay, so I've already there. I have R2 goes here. R1 goes here. So move this away. R4 goes here. R3. And it makes it way simpler because I always use KiCad, and so I'm looking at that other diagram, and it will look pretty much the same, right? What I'm doing here. If you want to draw a wire, you can do W, and It's a random wire here, and then you can right click and finish. And it used to be different key. I think it was K. I don't know why they changed this. It's pain because my keyboard has awkward. I need to lift. I need to use both hands to type, and you can undo Control Z. We just if you need this. So if you can start, it's a bit awkward, if you start from here and you want to connect it there, so it's easier, right? Okay. We want this to be correctly. It doesn't really matter this 1, 2, 3 for the potentiometers that we are going to use. But say if you have those retaining pins that you have separate holes in the board for this, you need to be careful of the pinout. So let's keep it the way it should be. Transform mirror vertically, so it's Y. Okay, so this is proper now. Okay. I'm just gonna wire it there, and if I move it, you can see KiCad, it keeps this connected. Okay. I'll just press Y, rotate this. This is going here. R is going here. And click, and you can move this wherever you want, For example, it's nice to make it pretty. Okay, it's actually C2 here. So this one is C3, E, C3, enter. This one is C2 on my diagram. Okay, enter. Okay. All right. Nearly done. Okay. So I need to do this here. And finish, yeah. So I have this named. So here is to kind of give a label to a wire or connection. So this is in. All connections with the same label are connected. Okay. Here we have this. Pinch. Now, we are missing ground. One of the things that I can see. And you have this special here, add power symbol. So you can click here, power, ground, GND, and so many different, right? Ground. Oh, cancel. You see my cursor there is with this plus. I'm just going to escape there. Now it's a pain to click all the time, so I'm just going to do copy paste. And I can still keep Control V. Let's make this a bit prettier. Oof, I didn't really make it much prettier. Now, there's grids and whatnot. You can change your grid here. I think it's here. Nope. Tools, preferences, grid. And you can change it here if you want it to be a bit more aligned. So you can oh, actually, this is a new thing. So this text is aligned at 10 mils. but wires are aligned. So this is just, you know, you can, maybe you can see the grid here, but anyway, this is just when you're moving your components, you see how it kind of steps. It's not smooth, it just steps to the next grid point. It's just easier to draw. But text is not aligned. It's 10 mils, so it's kind of in my trackpad is a bit tricky. Okay, I talk too much, so I'll try to speed this up. We have 9 volts. This is not strictly necessary, but I'll show you. Escape. So we're gonna go. This is going to be our filtering cap. It's not on the original. On the original diagram, but we're gonna use the original one used battery. We didn't really need it, or it was the original one. Original fuzz face didn't have it, so. But we're gonna have it here. Control C, Control V. So, well, this is not complete. So, I did not put any values here, right? So, let me do that. So you can do it here, E, and then you have value. 2.2U. You can here put more configuration, more description. You can do add more information here. We don't need it at the moment. There are some neat features. Some fab houses allow you to put actual component identifier, and you can use that for placement or fabrication of your, you know, of actual board. But we won't use that. We're gonna manually solder all of this. It's going to be interesting because yeah, I'll get to that at some later stage. But like the main point is to finish this diagram. So we have R. I can just highlight R and press A, and it's going to be faster. Actually, what's going to be even faster, and it looks like. I'm just going to use keyboard, and you can press M, and then you can move this and press enter, and it stays there. Yeah. All right. So another option is to do this is like we can do it this way. Now it obscures my diagram, but like, you know, I know that R1 from my, because I kept diagram the same, I can just put here. I know this is 330. This one is R2 is, if I can only find it, 33K. R4 is 8.2K. I press OK, and you see that's there. That's there. And I can, when I click on it, on them, you know, like here, C2, it highlights it somewhere. Okay, and that's 22 microfarad. This is the fastest way, I'd say. But like, it's a kind of a moot point if you do this as you go along, you know. But you know, since I did it very quickly, I did this way. So yeah, just one way of doing things, you know. But this is great because depends on how you prefer things. This just works. So here, this one is B1K. This one is A500K. Okay. That's pretty much, oops, right. Okay, this one zoom to fit. I prefer the fit, but because I think I have these elements, it kind of makes it a bit harder. Or maybe zoom to objects. Ah, that's it. Okay, you learn something new every day. So let me run ERC. So this is electrical rules check, electrical rules check, and something interesting we get here, and this is how powerful this is, because this gives you all these checks and balances. Now, of course, if you wire it up incorrectly, it doesn't know that you wire it up incorrectly, but at least tells you that something's not right. So label out is not connected to anything. All right, we actually need a jack, right? So yeah, makes sense. Label in, we need a jack. Okay, so I got rid of that. Okay, so and then it says, okay, hold on. This is power symbol, but you don't have power connected anywhere, you know? So this is very powerful. So let's sort that out. So let's say audio, what's the name? Say jack, right? There's connector. Okay, so we have power. Okay, so we have power, jack DC. Let's do that. There are other ones, you know, you have with mounting pins, you have loads of like this is the most common one, but because we won't be using battery, it's not necessary, and we're gonna be wiring it up with wires, so you know, we can use this. So I'll put this there, and then I'm just gonna click again, and I said jack. Okay, so we have connectors here, but these are audio connectors, and look at that, how many you have. You can even have these Nutric ones, you know, that you can add. But we are going to use a generic one because we're going to be wiring it up with wires, I suppose. And we're going to use just simple mono jack. Again, we don't have batteries or anything, so we're just going to do that. So I'm going to Control C, Control V, so I can move this here. Press Y because I want tip to be there. Copy this. We're gonna edit this, and I'm just gonna call it in. Okay. Doesn't have anything to do with this in label. I just want to, so this value will be shown on PCB board. Just a hint. So Y R O. Y again. Yeah, this is going pretty well. Tip. And again, doesn't really matter how you orient this. Doesn't really matter at all because this is conceptual view. We haven't even got into physically creating this. So okay, so here we need to be careful. Again, it doesn't matter in terms of we're gonna create a PCB with two holes and we're gonna wire wires, so we just need to make sure that we wire them correctly. But it's our diagram will be wrong if we get this wrong. So this is sleeve, this is pin. We have negative center, so I'm just gonna so just that's something, you know, very specific to guitar pedals. Just be careful about that. Okay, so that's it. Let's run ERC, and we have power input power pin not driven by any output power pins. So we need input power right here, and this is that indicating that. So what we need to tell it, possibly we could argue that this jack DC should be by default driving this as input power, but it's not. And I'm guessing the reason for that is that you can use this for whatever you want, right? So let's rectify this. So there is a special flag symbol that just, if I can find it, oh, power flag. It's a special one saying, yeah, this is where we're getting our power from, right? I'm just gonna put this, I'm gonna change this value to 9 volts. It doesn't really matter at all. And I'm gonna copy that, paste, and mark it here. So this tells the program that this is going to be actually used for power, right? That's how I understand it. There might be some better explanation, I don't know, but this is how I didn't see this. Okay, So that should be it, right? And that's it. Everything is fine. What I'm going to do now, I'm going to take a break and review this board once again. It looks pretty much the same, right? Let me see if oh, how did I messed up, right? Pretty close, but I'll do a thorough check, and then we'll continue on to the most interesting stuff. All right, I checked everything. Everything looks good. So I just want to kind of drive this point. Uh, I double check everything always. I check it many times. Now, I did it. I did kind of rush some things in, and inevitably, when you rush things in, you make mistakes. So just take your time, because this is, again, you don't want to send this out to be uh, manufactured, then you solder everything, and then it doesn't work. You know, that would be that wouldn't be great, right? So now we are ready to make the actual pedal ring. So if I go back here, I can either go, you know, I can either click here to open PCB in board editor. So this is board editor, or you can double click here. All right, so I double click there, and nothing happens. So normally you need to go and update PCB with changes made to schematic. So this is, if I click here, this will give me, you know, this will try to update the board, but there's something interesting here. And you may have noticed that when I was looking at the properties of these all these components, that, you know, there's no footprint assigned, right? So what does that mean? You know, like, we need to assign correct footprint to our components. So this is a conceptual uh, view of the board. So this is not a proper board. You may have different types of resistors. You can have a bit longer ones, 6-7 millimeters. You can have a very small one, 3 millimeters. You don't, it depends which one you want. These ones, you know, electrolytic capacitors, it depends on whether uh, voltage rating, for example. If you put very high voltage rating, now the program doesn't know that we are making um, guitar pedal, and we use 9 volts, you know. Well, yeah. But uh, it can't know what is the voltage rating of this one, and high voltage ratings, you can have a massive can there. On top of that, you know, you need to put correct transistor. You need to put so all these things come to play. So let me show you one thing. For example, here, let's say we go to properties here. Okay. E, and you can see that the footprint is here. Footprint is here. It's in line. Okay. However, if we look into more detail here, we can see that you can place it horizontally. You can place it like this. You can can have this inline wide. This is with formed leads. You know, so you need to know what you're ordering, right? So this is the point where we are going into, okay, what do we order? So what I did, actually, I did a bit of prep for this, and I need to close this, cancel. So I don't mind where you're getting. I mean, I usually use Mauser or Farnell, or, you know, even DigiKey, but like, you don't need to worry about these things if you're getting if you're with a small kind of a number of uh, components. It doesn't really matter, but like I like to order from these big companies. It just I always did that. So what you might find easier is sometimes to order from more specialized pedal companies, but pedal component companies, especially if you're looking for something that it's not really widely available, like, you know. Um, so that's especially true, for example, for foot switches, for example. Mauser has this one that we are going to use, but like in a more specialized shop, you might have way more. And you know, there's a limit of pots, there's a limit of number of knobs, etc., etc. But for most of the other stuff, it's probably easier to find all these components on a distributor like this, you know. So I prepared this bill of material. They have this bill of material tool, and I'll share this. I'll try to share it if I figure that out. But what I wanted to show you here is this one of the benefits of going through distributor. You can, you know, you get all sorts of extra information, or you know, like data sheets, for example. In lots of cases in more specialized shops, you know, some, uh, not all components have data sheets. I'm kind of a bit anal about it. I like to go through, check everything, you know. But here, this is my point, you know, like you can have this case, you can have that case with, you know, formed feet. Um, doesn't really matter. This one is awkward to solder if we use this footprint, but you can always use pliers and, you know, form this feet in a similar way. It may not look as pretty, but like just that's the point, you know, like here it's going to be this one. So yeah, well, nice name, King to Lead. So you know what you're getting. Sometimes, you know, I want to, and this is another point, a very important point here, is that lots of these photos don't 100% reflect the actual component. And if you notice here, this one is, for example, this one is nearly green. Now, when I was looking for LED, I was looking for red one, and so I searched and I found it. It was, you know, like if you know what you're looking for, you can find it. Now, sometimes takes a bit of time to figure out what you're looking for, okay? But here you see it's red LED. And if you click into datasheet, you know, sometimes it is, but you know, you need to find it. Emitter color, super red. Okay, so these are my components, and this is what I'm going to use. Okay, and as I said, like you can't really, you have to do this prep work if you want that to work. So what we're going to do is I'm going to go and open here. First of all, we're going to cover resistors, right? So resistors, I wanted to take small ones, 3 mm, because I wanted to make the board as small as possible. Unfortunately, I couldn't get the same from here, so I got these. I was trying to get the same component manufacturer. Doesn't really matter. Resistors, yeah. So it should say somewhere here how long are they. I think they're 6 mm, and you can get into all crazy stuff here. But they're 6 mm, 6.3, I think. MFR 25, MFR 25, yeah, MFR 25. So that is MFR 50S. What the hell? That's miniature version. I would have to read what exactly all of that means, but I checked it last time. So 6.3 mm. Okay, so let's do resistors first because that's easiest. Okay, so we go here. datasheet, we can always fill that out. We can put footprint and resistor. Now you don't need to do it this way, okay? Sometimes as you go along, you can do. One good idea is like, you know, you put your footprint on the first resistor that you put and you just copy paste everything, and then, you know, like if they're all the same footprint, you get that. I normally do that actually. And just now we need to find the one you're looking for. It's through hole 6.3. This one is vertical, we don't want that. We want this one, 6.3. So you see it's going to be really tight, which is okay. You can, you know, give yourself a bit of a breathing space if you want to. No need. We'll push it to the limits. Okay, so here you can see it's there already. I'm going to copy paste that everywhere. And oh, okay. And now we check this. This was it was that wide, and I lost track of it. It's here. Okay, so we're gonna save this, and we know that these are already there, and these should now appear on our board, right? So I go and I'm gonna click here, open PCB. Nothing appears. Again, update PCB. And you can see that we have less errors. There were 13, I think, or something errors. Now we have only 9. You say update PCB, close. And yay, we got them there, right? Now we didn't do much. This is just first step, just to show you some. This is really first step. You need to have the components. This won't work without components there. Let's see, we can see this in 3D viewer. And let's zoom out, and it says board outline is missing or malformed. Then we're gonna get to that. But you know, like, you see, beautiful. Those are ours. And I probably messed up the, I messed up the, okay. We can go back to schematic, and I messed this up. Okay, what did I do? I did 2. Okay, so 2 pins. How did I miss that? I talk too much, I think. That's how this happens. All these things happen when I talk too much. Yeah, there's so many, you know, like there's over 13,000 footprints there, so, you know. Now, we want to put these pots, for example. We can choose between these, you know, pots that are with solder lugs, or we can do these ones with pins. I'm gonna try both. Unfortunately, as I said, like one of the downsides of ordering it from and actually the potentiometers require their own video completely. It's gonna take forever to explain how to look at this, you know. See here, you need to make sure that you're ordering correct one, the size, there's so many variations. For example, these ones are with straight pins here, but they're those with angled pins here. I wanted those, but Mouser didn't have them in that size that I wanted. So, you know, you at some stage, you know, if you're not getting this from a specialized shop, you might have to go deep into these data sheets to figure out which one you're gonna get, because this is not. I already made this mistake. I went by image. An image may not be correct, and they actually saying that when you go and you go to the details, it says image is not, it's for reference only, see product specification. So, you know, they covered their ass. I was caught by that a couple of times, but I learned my lesson. So I tell you now, so you don't have to relearn it. Okay, so yeah. So let's do that for PCB. Now for PCB, we can go and press E to edit this, and we're gonna go footprint here. Because we are going to solder this directly, so we're gonna go do it either through wires or we're gonna go through with this one. And you can see here, this is standard spacing, or is it? Oh, this is 5 mil. Yeah. So, you know, we might need to be careful about, you know, how big of a distance this is between so that's the next thing, getting this right. Okay, because I'm going to use this one, for example, but I might also use those with the soldering gloves. So we're going to cover both, but we just need to make sure that we get these, or I ordered this one. Yeah, I'll double check now in background. So let me double check and I'll get back. I'm back. So I checked. So it's 5 millimeters here. And we ran into our first problem because I couldn't find footprint for this one in particular. Normally, if I want to do wire soldering, you know, like I just use header, and I go and I find, say, 254. The problem here is this one is, you know, this one is 5 millimeters, so it won't work. I don't want to go into this right now, but I suppose this happens more often than not with components that we use. So let me show you. So the way to do this, if you don't have a component, one of the options is you got it from, say, for example, Mauser. They normally have this ECAD model. They have loads. So for most standard components, you'll probably find it in KiCad. But like here, you might enter a situation, run into a situation where this is, you know, this is what's going to be needed. So here, Mauser gives you an option to download these CAD models, and you can just download, and that's it, you know. The thing is here, you need this, what is this called? It's component search. So you need to register on that website, but then it downloads it, and that's just one of the ways to do it, you know. Let me see. Where did I download that? So I downloaded it here. If you go in, this is zipped up. So, you know, you go here, you can find KiCad, and then you need to know just what is what. In our case, this is what we're looking for, KiCad mod. This is the file that we're looking for. Okay, so let's set up our folders first. So this is our project, and there's loads of autosaves, backups, whatnot. That's internal works. So I'm gonna create a little folder here. I'm gonna call it libraries. So I'm just gonna keep everything together, you know. Libraries, and then let's call it footprints. And then I can, let me, while I'm at it, I'm gonna add my logo there. We're gonna use it later, you know. Uh, but I'm also going to add this here. We're gonna copy this. So what I did was in there are different ways to do this. If you're using everything on your local machine and you don't want to distribute this, you can have it in your documents folder and you can set it up. And in KiCad, it'd be good to do that now. Because I'm going to zip this up and make it available, I just want everything to be kept in one place. So I'm going to keep it inside my project folder. There are various ways to do this. You know, your mileage may vary, depends on what you need to do. So let me set up KiCad to use this now. I don't need this anymore, I don't think. It's good that website, when I clicked here, you see it gives you the symbol, it gives you footprint. You can request 3D, which is like, you probably won't get it, but like, who knows? I even have somewhere on my website, I did one 3D model. It was great experience. Took me forever to do it. I wouldn't recommend it if you don't know what you're doing. I had no idea what I was doing. So it was fun, but you know, not something I like to try things. If you watch my videos, you know I like to try things and I'm not afraid to fail. So let's set this up, okay? Let's do preferences, and you can, you know, you manage your symbol libraries, your footprint libraries. So in this case, it's footprint, and we can, you see, this is your folder here, your project, where your project folder. These are your standard global libraries, you know. And if you have more, so if you want project specific libraries, you add them here. So what do we do? Add empty row. Well, add existing. Okay, we're gonna do this, and it's in here. So we just click here, I think. Footprints. And I think if I add my logo, okay, here, right? Ah, look at that. I need to delete this. Oh, I don't know what it was. Okay. That should be it, actually. So let me go back to my schematic. Whew, took a bit. This video has been getting longer and longer, right? So normally here it's in footprints. So you just need to find this. Ah. You see footprints here? I know I just need to clear this up, and it did not keep the. Sometimes this used to work in version 7, yeah, probably. F, where's F? Okay, there it is, footprints. And it's here. Okay, let's put this on the board. Let's set this up, and then we're gonna continue with we're gonna see how that works. So I'm just copying this, and we're gonna see how that works in on the board. You can also double click here, okay, if you want to do that. So this is now saved. I go to the board, I update. Oh, we have 7 errors now. Now remember we updated this one. You see, it recognized that we changed Q1 footprint, if you remember, because it was so long time ago. Okay, close, and we get these massive ones, aren't they? I may have taken too big of the. Oh, what did I order? 181. Yeah, it's the same. That's okay. That's correct size. It just, I never used this with such a wide, well, actually I did use this. These are normally like that. Okay. Anyhow, if I look at 3D viewer, I won't see this because as you remember, I asked for, it tells you you can ask for 3D uh, model. You know what? Let us finish everything else and I'm going to try to find 3D model for that. Okay, so what do we have here? So, things are getting a bit messy. Okay, so let's do this. So capacitors, not so important, but still important, okay? Because, it has these capacitors, they have two leads. You can fiddle with them, you can bend them, you can do whatever you want. So, but like if we want to be really pedantic, we need to look into the data sheet again. And this is good to know how to read these. Uh, Worth electronic. I like them, they're red, but they're actually high quality capacitors. So let's go and have a look at this. So what we really care about is, pin diameter is pretty standard, and we can check this pin diameter is here, it's 0.5. We don't really mind that. Normally, what we care about, because we are putting this into enclosure, and I forgot to talk about it, we might need to care about this height, okay? Sometimes that's important. For example, L here is 11 millimeters. This is very important though, because if you're fitting potentiometers with retaining pins, the 9 millimeter ones, they're actually, you won't be able to fit this on top of the board, and you want to screw that onto the enclosure, you won't be able to fit it because this one is going to press against the top of the board. So you might have to fit this underneath the board. Just one of the things, so you see here L 11. What is little t? T is just variation, or what's the proper term? I can't remember now. But this height might be anything between 9.5 millimeters and 12.5 millimeters. So something to be careful about when you're ordering. Likewise for this width here, you can see it here, it's 5 millimeters, plus minus 0.5. What we care here about is this A, and in some shape or form, you'll find this everywhere, in all, and in all data sheets. I have all worth. I'm butchering that name, but that doesn't really matter. I hope nobody from that company is watching this, or maybe if they do, they can tell me how this is. How do you say it? But you just need to see this A here, the size of this, and possibly diameter D. So A is 2 millimeters. So how do we get that? Oh, which one was that? I was like, I can't talk and think at the same time. So I was looking at this one. So this one is 2.2 microfarad. Okay, 2.2, 2 millimeters. Gotcha. C1 footprint. Whew. So, okay, you see, if I click here, you can see here it's L. Remember that? That's 11. Diameter was 5. P, what's P is 15 millimeters. Oh yeah, yeah. So this is, what is this, axial? Yeah, so that's why it's 15 millimeters. I was like, what? So we need to radial. So you go here, and sometimes I think this version 8 is a bit messed up. It doesn't click all the time. So might raise a bug for that. So here, you know, for radial one, you care about diameter and the pin pitch. So this is exactly the one if you remember. So it's 5 millimeters and 2 millimeters. Okay, we take that, done. Save and continue. Okay, so we go back, and this is going to be a pain, right? But we want to do it right. Again, if you have a capacitor that's not exactly this size, you can still fit it, you know, unless you crowded the board and you can't physically do this. You can always put it on the back of the board or something like that. They're ways to get out of a bind if you get stuck, you know. So this one, again, I'm not gonna go into two. Which one am I looking at? 22 microfarads, a 2 millimeters diameter. Hey, diameter is 5. Same. So it's same. Copy, paste. Okay, I'm gonna stick to electrolytics. So 47. I'm just gonna close this. And this makes sense. I think I got them all the same. I'm not gonna go. I'm getting into too many things now, but it's same rating, voltage rating. You know, as long as it's over 9 volts, it should be okay. But keeping in mind that they lose performance if you're closer to the intended voltage, so it's better to have this a bit higher. 25 volts is great. You know, I think it's going to be fine. When I say I know it's going to be fine, I think it's great. Okay, here, what you know? Maybe I was going for this. I did this bomb so long time ago, and okay, it's the same. Whew, I must have gone. I should, yeah. I rock. Um, okay, let's see this one here, film capacitor. I used TDK. You know what? It's a bit more expensive. Yeah, it's 33 cents. But this should be really good. And it's blue. It looks nice. Yeah, world is better in color. And you go in and you see that this one has totally different. But these film capacitors are normally shown like this. They have a bit slightly less variance than I think electrolytic ones. But no, I think Worth is doing that thing that they have datasheet individually for every capacitor. Normally, lots of other companies, most other companies, they give you family, so you then need to go and figure this out. Okay, so okay, 871B325. Is this 871? How do we find this? Okay, there's okay a note here. This is Mauser's number. 871 is just their probably company ID or something like that for TDK. This is your manufacturer's part number, so MPN. Let's call it MPN. B325. Okay, I'll never forget that. Never remember that. B3259. Yeah, so okay, here. Okay, so here, found it. Oh, it's 5 millimeters lead spacing. That's all we care about. Again, I know we care about height, we care about width, obviously. So I need to find that. But like this is 5 millimeters, that's good. Where do we find? This is ours. V. Man. Isn't this exciting, huh? Not really. Um, ah, maybe I should have just searched by this. No, C103 is just 10 nanofarads. That. Okay, 10 nanofarads. It's here. What's our 63 volts? 63 volts. I think this is ours. Width is 2.5. Oh yeah, I could have searched by it, right? Oh man. And it doesn't do the search. Yeah. That's the one, right? I don't know why it doesn't work. Um, so it's 2.5, 6.5 height, and length 7.3. I think this is pretty standard. Okay, let's do this. Capacitors. TH. Oh, okay, it should be here. All right. So we have, what do we say? 7.5. It's not disk. It should be this one. No, it's rather, no. It's not big. Oh, rectangular. That's the one. L, what do we say? L, where's this thing? 7.3. Okay, 7.2 is okay. That's maximum dimensions. Okay, 7.3. Okay, 2.5. P is 5 millimeters. That's what we're looking for, right? Okay, that's the one, I think. Let's see if this is in any way different. Oh, it is 3 millimeters. So no, this one. Okay, got it. Got it. That's it. Let's see 3D. I don't know. It's always cool to see it in 3D, right? Oh no, I didn't. Update PCB. Only 3 errors. We're getting there, people. We're getting there slowly but surely. Looking good. Looking good. A note here. See how this is highlighted? If you don't know where to find, these are selected here. So if I unselect them and go back, oh yeah, I didn't unselect them. Press escape, or I select this one, for example. Select this one. Maybe I do this, right? So I select this one, Q1, and it should, yeah, highlights this one. So I think this is cool. It's very good. Okay. What else are we missing? Okay, we're missing only these 3. Okay, let's discuss that. So at this stage, like with these 3, we need to know what components are we going to be using. And I have this here. We just need to be careful what components we choose. This one, I think I haven't used this one, and I hope we get this right. That this is going to slot into the that I can. So let me click on it. So that we can screw this on to our enclosure. It's plastic because we use negative center. So if it was metal, that would touch the and our positive pole would touch the enclosure. So that would be great. But the whole point here is there's so many different options. There are options that are going to the PCB, they're not going to the PCB, etc. So here we are doing this chassis or whatever the name is, how we attach that. So we need essentially holes on our board. So what I'm going to do is here, I'm going to do this like, I'm going to do, say, header, pin header, and you can have different spacing between pins. That's easiest for me, I don't know. If you have a better way to do this, let me know. But we go and we say here, so this is going to be our footprint. So we're just gonna wire solder two wires there and connect to our DC connector, okay? So this is fine. By that logic, we can do this, the same thing here, right? We do that, right? Because what we are going to do is, I chose, what did I choose? It's here. Yeah, I chose these Switchcraft. They're high quality. One's pretty good, but you know, mono, two connectors, etc. I put them, so I forgot to say we are using this 5090A small Hammond enclosure, and I have loads of them, and I tried them, all these components. Most of these components I tried already there, so I'm pretty certain this is going to work. So let's update our PCB again. No errors. Okay. Just, whoa, hold on. There's 4 errors now. Okay, let's see. No one had found for. All right. So we have these, and one thing to notice: this is called rats. That's rats. Wires. What? I don't know. These wires, these lines are indicating what pins are connected, right? So you can see here, these ones will be connected, and when we start routing this, it will be important. But here, see this one, J2 and J3, in and out, they don't have any connections, which is clearly wrong. On a closer inspection, the problem here is these pins are T and S, okay? So either I change this symbol, and I could edit this, you know, like I can do this, you know, and this is just, this will do it just on this schematic. So maybe we do that, right? Pin number, say this is sleeve is going to be, no, tip is going to be 1, and we're gonna have sleeve being 2, okay? So we can change this. Nothing prevents us from doing this. Let's say this. I saved this. Let's update PCB and see if that works. And all of a sudden it works. The other option is, and I think this is okay, because we have only 2 components. It's not a big deal, right? But if we wanted, we would have, if you want to do this more like systematic, more repeatable, you would want to create a separate symbol there. So we're just going to change this as well. Let's do that. Edit in with symbol editor. And this is very simple. I'm not doing anything crazy, you know, like I'm just changing tip to be 1, pin number 1, and sleeve to be pin number 2. That's all. Nothing else. So I'm not going to go into details of how you do this. It's, again, it's simple. It's just a bit time consuming as well. So with this, we have everything here. I'm just going to update here. No errors. This is great. We have everything there. So it's time to start routing our board. finally, after say something like hour and a half, is it? Uh, There are, so now when we start routing this, and let me just zoom out a tiny bit, or we zoom to objects. Okay, so we have all of this here. Obviously, these are going to be at the edge of the, that's not obvious, but like this should be at the edge of the board. But one thing that we need to be very careful is how, one of the key things that we want to do is we need to figure out how the board is going to look like. And the main thing here is what is the enclosure, because that gives us the biggest kind of a limitation is the enclosure. So if you click here, go to datasheet, and then this is not right. It got us to a wrong datasheet. Yeah. So we really should be, so this is, you know, sometimes you need to do roundabout way, because these are just dimensions, but you really want to go and see, let's find it here. Okay, I wanted this. So we're going to go to this one. It's going to give us a bit more details here, and what it's going to give us is, more importantly, you guessed it, datasheet, or in this case, drawing, and we'll go to PDF, right? So it gives us all the most important information here, right? So what do we have? First of all, how are we going to mount it? We're going to mount it in this position here, because the way I chose, and this is unfortunate because the other way around gives us better uh, gives us better flexibility if these were bent down. And I have those at home, but I wanted to show how you would go around if you needed to order everything from scratch and you had maybe some limitation of who's, you know, who's shipping to your place, cost, etc., etc. So you have some options here, right? But that comes with limitations. Again, these are physical components. So we're gonna have these. So how this is going to fit is, this is going to go on top, and our board has to go down, right? Down. So that means it's going to be in this plane here. So we have some space. So how much do we have? We have height is 27 millimeters, okay, but width is, what is the width is, you see, inside width is 33 millimeters, 33.7. Now we have to be a bit careful. All of these have certain variations, so you don't want to be really tight. I did that before, and I had to file my boards slightly because they had little tabs on the side, and I was just, they came on a panel, and I had tabs on the side, and I was just barely fitting. I had to file those when I cut. Anyway, it's not important, but like, it's important to know that, and what the limitations are. So we're talking about, here we're saying 27 millimeters. This is going to go all the way to the lid. Problem, lid has slight width, so that limits our inside width for maybe a couple of millimeters. So these are all things we need to be careful about. You can't just go and do random stuff. This is now, we need to be able to fit it. We need to know on which side we're gonna fit it off the enclosure. So if we put, for example, pots right here, you can't fit them on this side, right? Because board is gonna hit here, and more importantly, there are these screws that go in. There these, what's the name? I don't know what the name this is. So you screw the I don't know the technical term. So you screw them in here, but that is, I hate this. I always struggle finding. Okay, so at least 4 millimeter diameter here. So that cuts down your available. Oh, actually, it's here. Yeah, 22 millimeters versus 35 millimeters, you know. So we are talking about 35 millimeters really. So these are the things that we need, and I spend a lot of time on this, but it really is important. Okay, so let's, with this in mind, it's gonna be easy to draw this. So we are talking about 35 millimeters and what did I say? 27. 35 and 27. Let's see how long I remember that. So here are our layers. So we have front copper layer, and you can hover here, back copper layer, you have solder paste, etc. Silk screen. We're gonna come to that. We don't need to worry about most of them, but you know, we'll see what is important. But the one that we are caring about is this edge cuts. Okay, so we're gonna, what edge cuts are, how our board is going to be cut out, and you can go do fancy stuff, you know. But here we all only care about 35 by 27. Oh, I remember that. That's good. So here you click anywhere. So you see above, you're gonna get the what's the name? Length. So we're gonna go. This is going to be our, and here we can't get it exactly right. So I'm gonna change. You see, this is the grid. So we're gonna see how this is what, 25 what is it, 0.6 millimeters. So we're gonna change this to be a bit, I didn't feel like this was that, I felt it was a bit bigger. Anyway, let's see. Definitely, oh, 0.60, yeah, it was that. So why didn't I get it right? 25.4, 24 points. Yeah, we'll go with that. Okay. And then we can go down 35 millimeters. Yeah, we can go 34.925. So these are some kind of a standards. And you can see how it snaps in and tells us, okay, I'm gonna connect it there. You see that cursor there, and that's our board. So let me save this. Let me move this, and I'm just gonna put it here. And this board is too small for this, it seems, but we'll make it work. So let me save this. And what I want to show you is like 3D viewer. Notice how that wording there is gone, that we don't have the board. We now have it. This is the board. And isn't our board beautiful? Not really, we're missing those spots. If you remember, we added them from third-party website which did not have 3D models. And I'm not going to put 3D models. It's unfortunate. It would look so cool if we had them. But at some later stage, I'll add boards with 3D models, and we'll see them in its whole glory of this. But like, if you saw some of my other videos, you'd see 3D models there that look pretty awesome. Okay, we're finally in position to route our components. Okay, so let's do that. So how I normally do this, there's no hard and fast rule, I suppose. I like to put my, say, inputs and outputs first in the spot that I want them. So I'm just gonna move this out of the way. Move this, put it here. So these ones are going to be tough. They're going to be very tough to fit, I suppose. So let's do it something like this. Let's get them as a reminder. This is our width of our enclosure. So these should go here. Just be careful where you put them, you know. Let's read, and I press R to rotate them. It's same as for the schematic. So here you notice it was red. What these purple circles are, their courtyard. So these are, if you see here, there's front courtyard and back courtyard. This is just, we shouldn't be overlapping our components. Here, it's tight, right? So this will show up in our checks, you know, if we will might need to ignore that. But as you can see, we will probably be able to fit them. I think in the end, I chose a bigger pots that I should have tried slightly smaller ones. But this will fit in the end. If I press M, I can move this with my keyboard. So yeah, I'm happy with that. Enter. Okay. It's going to be tight. One thing I noticed is that, see, this footprint is 1, 2, 3 here. Let me see, I was caught by this before. What I noticed was this, that numbering does not look right on the pinout. So let's see. So we see 1, 2, 3, and 1, 2, 3. So you have to be always careful because you see here it goes 1, 2, 3 this way. I'm just trying to visualize how am I going to put it into the how am I going to put it into the enclosure, and this is actually, this is correct. So I got a bit confused here because it's 1, 2, 3 and I don't want this. But how am I planning to fit this? If you think about it, if I look it from this side, this is going to be 1, 2, 3, and this is correct. I want to flip it, so I'm gonna flip it because how it's gonna look like is, let me first flip it, change side. So we flip it F. Oh, convenient. F. So I'm gonna now rotate this R. And flip it again R. Okay, so this is going to be from the bottom side, and on top we'll have all our components. That way we can move this board all the way to the wherever we want, really. So we are not limited to the, remember when I was talking about this here, we can put it all the way to here. Depends on how we want it, you know. But we'll need lots of space here for our other components. So we just, this gives us a bit more flexibility. So I think this is correct now. Okay. I was freaked out for a bit, but I was caught before that this, especially for pots, I think it's confusing how to look at this, and in lots of cases people don't really care to properly put numbers in, and I think that's, you know, something to be, we just need to be careful about that. So now these two were critical components. The reason why I'm saying this is like we can't just put them anywhere. As you can see here, we'll have some room at the top of the, so this is actually incorrect. So I need to move this a bit lower because we are fitting our things all the way up to the top. So we can't really afford this space. So later on, we might even move this down and make our PCB smaller. In some cases, it is a bit cheaper if we are not going to do anything here with any components, you know. We could put components here as well if we can fit them, but we need to be careful what we're doing. We need to be careful about the size of components, width, etc., etc. So it's a bit tricky. Ideally, we won't put anything here, okay? And I still haven't started routing this. This is getting out a bit out of control. Yeah, I'm out of control. So let's put input, and our input, I'm just trying to visualize it's going from the right hand side. So this is our right hand side. Maybe I just rotate this, yeah? R. Okay, so this I don't need to strain my brain. So input is here, output there. Or we're gonna rotate like this. I don't know. We'll figure it out. So one point when I was flipping this, so at the moment this is on top of the board. If I flip it, and I flipped it now. Okay, so let's see 3D. I pressed F there. Let's see 3D. You see these two? This one is flipped. It's on the bottom part. We are not seeing, as I said, like we don't have 3D model for this, for the pots, which is a shame. I still can't get over that. So we need to be, where are we going to put the jack for power? Let's put it here for now, and we'll see. I'm gonna flip this back. Sorry. Okay. All right. We have a few things here to put in. One of the things that I just want to briefly mention, yeah, courtyard are important, and notice that this changed to teal color. I don't know, this bright bluish. We have this fab, what you call them, layers. We don't really need them. They're giving fab house when they're doing their placement, or you know that gives them a plan where what goes where. So it gives you the designator, the values. We don't need that. We're just gonna hide that. It just declutters this a bit. So let's move on. And at this stage, we might start placing them in the order we want them to appear. So, for example, this output, and this is where, again, another thing. So you see here, when I double clicked, you can press E the same way. It's pretty standard. But here, you can put reference, and you can show it, or you can put, but I don't care about the reference. I want this to appear. So I'm gonna just hide this. And this one, I don't know where did this go. There used to be a layer where you want to put this. So I'm just wondering what's happening here. This is new. Okay, that changed. Okay, so we're missing here. Let me just get this back. We'll figure it out now. So I double clicked here and it appears on my layer. This is unfortunate because in the previous version there was this was in that grid, you know. So I'm gonna put this on silk screen, okay? And silk screen layer, we're just gonna hide it. So these are designators. So they give you, you know, that writing on the board so you know what is there, okay? So we're gonna put this on front silk screen and you see how it changed the color there. It was gray and now it will stay there because we are going to put that in. We're not going to show this and I'm gonna press E now this time. Yeah, that drop down with layer was here before, so that changed. That might be a bug. So M, move this slightly. But we'll make this board pretty. We're gonna move these designators where we see them fit. I'm just gonna move this here, for example, because this at the moment is out of the board. So we're just gonna put it, let's put it there. And there. And let me save this. Now we're gonna start, you know, stacking stuff. We're gonna go from input to output, and we'll see how that goes. Actually, I just remember I forgot to add a couple of things to this board, and I think I said earlier that I ordered two types of potentiometers, so with these soldering lugs, but I also ordered these PCB standoffs. And these are 4mm standoffs, so in case we want to use, you know, with pins, the potentiometers with pins that will hold our board in place, but if we don't have that, we can use standoffs. So I forgot to put those holes there. So let me just do that. Mounting hole, okay, we can do that. Yeah. I'll paste this, copy paste this 4 times. Let's see, maybe we leave it 3 times, yeah? 3 is enough. Yeah, we'll make it work with 3. Okay. I'm coming up with this on the fly. And actually what I'm going to do, I'm gonna add my logo, Enclosure house. Okay. We put Enclosure here. So I don't know, maybe there is a better way of doing this, but what I do is I put a footprint here, one that already exists, and I think I called it logo. Let's see. And I hate that I can't collapse all of this. This is something that would be really great. Logos. Let's do this small one, yeah? I'm not gonna go into how you do this, but just, you know, I'll cover that at some stage, maybe. Mounting hole, there it is. And we want 4mm, right? That should be okay. M4. No, it's 4mm. I think it's, yeah, it's 4. I checked, and that is what I ordered. 4mm. Okay. Of course, as I said, it's always a good idea to double check everything. So what I'm going to do is I'm going to print my board in the end and make sure that everything fits. So let me update the PCB and I get this. All right. So you don't really mind this. So what I'm going to do, I'm going to put it here. And I'm just going to put these. It's a bit of a tricky one to visualize because we don't really mind where this is going to go. Because if we are using the one with soldering tabs, these pots won't be there. So now, is this a good idea to do it this way? Or maybe it's not, you know, but something to just be aware what I think this is going to work, to be honest. And you can see my logo, and it's going to be probably all, we put it here and we put it on the top because that's, yeah. Yeah, could probably do it better. I don't need to see this H3, H2, H1. So I'm gonna just E, show, don't show, because we don't care if it's 1, 2, 3, 5. So at this stage, I'm just gonna leave this tiny bit. Yeah, I'm kind of running out of space. I thought. We'll see how this is going to work, and is this going to work out? We'll figure it out. So might move this a bit here. Yeah. Okay. While I'm at it, I might as well show you how to add 3D model to this, I suppose. Let's do that. I was looking up, I remember I was looking up a while back. I think we can, so if you don't find, remember we found the what we were looking for, the footprint. We went through Mauser and we went through this, you know. Yeah, there's no 3D model here, right? But if we go and we go to, let's do that, right? Okay, chargers. Yeah, we can do everything through this, right? Okay. Commercial panel controls, I think that's where this is. It's a bit slow. But here, we can go and find, so ours is PDB 181, right? So if you click here on here, looks the same like that. So I have K420K, okay, P 181 K, and not all are available. Do I have this K420K? So we don't really care. This is 1K. Single. Let's see what's there. There's no 3D model. What? It doesn't really matter. and you need to know what you're looking for. This K means it's just it's with pins. 4 means it doesn't have center detent, and you look it up here, no detents. And then shaft length is, so it's 420, means 20 millimeter shaft, and there is a shaft style. So that's how I chose them originally. So, but that also means that it doesn't really matter if it's K20, even if it's 2. 2 just means it has detent and makes no difference in the 3D model. Oh, okay, we have it here. So I can download this CAD models. There's a bunch of these. I'm not sure. I think I used STP before. So let me download this. Yeah, the file is here. So let me just copy that into my... Okay, I have it here. Libraries. I normally create this folder here. .3D. And then I just copy it there. So now that I have copied this, okay, can go back. So the best way to do this is to go to, let me go, the best way to do this is to actually go here, manage footprint libraries, oh no, footprint editor, okay, we go there, and we just need to find our custom footprints. Here, double click, and this is our footprint. We can now just go and go to, there should be properties here, footprint properties, and here we can go and check 3D models. Okay, we can do this, and of course it goes to a random place. Libraries, footprints, 3D, this one. Okay, found it. Right. Now, it's a bit off here, so we just need to make sure that we adjust these to rotate it properly and do everything that's to make it fit the, you can't see it here, there's a hole there, there's a pinhole there, so let's rotate it. I don't, okay, so it needs to go like this. Okay, we need to rotate, no, this is, this is what we want. Okay, so this is right, so we need to get it up, Z up, and I think this is correctly placed now on top of the board, and we just need to make sure that we cover, I normally look at it from here, and then I kind of, okay, this is, that's all right, I think. Keep in mind that this is just 3D view of what you're going to put in, and look at that. It matches nearly perfectly, right? And keeping in mind that this might be 20, this might be 25, but they look the same, right? The body is the same size, everything else is the same, okay? So I can save this, save, that's it, done. So we updated that. Let's see how that looks like on PCB. 3D viewer. Okay, and it's not there. The thing is, what we need to do is we need to, I think we need to update footprint from library. and we do update footprints with library ID this. So we are going to update all 3D models and the actual footprint. So 3D model is the only thing that we change, so that's it. So double click or E, update footprint from library. Okay, save this. Let's see, 3D. Hey, look. Okay, let me zoom this out. Nice. That's exactly what I wanted, right? Okay. Okay, but I only now realized that I forgot something. Okay, so remember I was talking about LED, but I never added an LED. And did I add? Oh yeah, I add 10K uh, resistor here um, for the 3 mm LED. This is like one of those low current ones, but I forgot to add those. So let me just go and rectify this. And actually, let me go back real quick to the diagrams here. And so here, uh, when I was assembling it, let me see if I have it here. There's a full bill of material, but remember, I completely forgot that we are actually wiring up. All we need is this in and out coming from this board, and we have this LED minus, so for our LED. So I completely forgot about that. And this is going to be a bit, this is going to simplify our board. We also need to remember that and ignore battery, that we need to wire these, say, properly. We're gonna have one central point. This is our central point, and everything goes there. There are no loops. So I completely forgot that. So let's fix that. So all me talking about fixing this, etc., etc., we don't actually need this anymore. Nor we need this. Okay, let me just delete this one here. And I could have kept it the way it is, but it's going to be weird. This one is okay because this is actually where this connection is going to happen. But here, I need to put just one pin. Okay, how do we do this? Yeah. Okay, this has mounting pin. We don't want that. Oh, con. Okay, connector. Con 01. Oh, there's socket, right? I don't know, this one. Let's use this. Okay. And I can't be chasing now what it is. So out. Just gonna copy paste this. Wrong one. Paste. Okay, we have here in. Have to fix this. And I'm sure. Come on. I don't like this. I don't like the look of it. Ah, this is what I was looking for. Okay. So E to edit, just keep oh, out. Oh, I didn't delete this. I didn't delete this, so let me. And footprint. Let's do that. Just copy that and paste it here. Saved. Always run ERC. Done. Okay. We need one more. And remember that LED minus from the previous diagram. So that's it. And we need, I'm just going to copy this one. This is our let's see if I'm gonna. Oh, what did I do? LED. That's it. Escape. Okay. And I'm just gonna copy and paste this here. We need to change this, so we're gonna do footprint 3 mm. I'm just gonna find its LED. LED. We want vertical. I'm actually. So how we might fit it, we might need to bend. Well, we'll see when we place it, but it's just something to remember. Where's vertical here? Yeah. Oh, done. I think this is it. Uh, when I copy pasted the previous one, it copied footprint there. Once more. Oops. What did I do? I don't want that. Run ERC. Done. PCB. Update. So it's gonna remove those that we changed, and we're gonna have the new ones here. Okay, so oh, it did not delete these. Poor. Should have deleted this. I thought it would. So there are, you can delete footprints with no symbols. And if I do this, I usually have that ticked, I think. But what's happening, that's why I added these holes in my logo there as schematic, otherwise they would get deleted. Okay, so we're getting more and more of these on the board. Let me just do a quick one here. I didn't want that. Fab. Out. Front. Silk. Okay. It's a bit tricky, so much information on this board. So now I'm just gonna go edit. I don't want to show this. I don't care about J1, J3. We're gonna be wiring them up. We're gonna put wires through that. Okay. All right. Whew. Now we're running out of space for sure. So in this side, I think that's what I said, right? Okay. Out. Yeah. And our design checks will check whether this is too close to the board, to the edge of the board. That's why we added all those rules. Let me hide this fab. So have some room there. So let's put this LED and this R5. So I'll just move. We won't have room on the board to move it somewhere else, so it'll probably need to go like this if we want to keep that. It will obscure it when we solder that, but at least we'll know where to put stuff. By all means, you could keep 10K here or whatever if that's easier for you, So, because this is going to go vertically, we'll probably put this somewhere here, okay? And we're gonna just bend this up, I suppose. Let me put it a bit down. And I'm gonna put this R5 here. Let's say here. No, it's the end of the board here. So this is going to be a bit tricky, just because we are running out of room here, okay? So I'm just gonna try to fit it. We'll see how that goes. Let's do a quick check with we're gonna look at this, but yeah, this is not good. Let's call it power. You always have to update this, right? So we're gonna keep this on silk, and we won't show J1. Notice how there is this line here that just points where to your component, so you know which one you're touching, moving, doing stuff with it. Ooh. And now it's going to go and be tricky. Okay. Did I move? Oh no, this is LED minus. Okay, let's see. 3D. Okay, notice that this is going to be very tight because just the way this works, so we might need to move it a bit down. But as you can see, we do have some room here where we can fit our components, so it's not a problem. So we are not fitting component, we are just need to have enough room to solder our component and not touch any of the metal parts here. So we're just going to move it here, and that will work. Okay, and with that, even we could even fit resistors underneath. Now this is not, I would always suggest you go in and check with physical components, okay? Oh, I thought I had this there. Totally missed this. Oh yeah, it's here. So this one will fit, right? So I'm just gonna put this down. Mm, we're just going to move them below. And I'm not too worried about this. Let me move this out today. I'm not too worried about this because this is 4 millimeters and a couple of more millimeters to the side for the when you put the board on. But this should be okay, I think. I mean, let me move it to the side. So we just have enough room for this, right? And as I said, this is not, hard and fast rules. You might do things based on your preference. But sometimes, and I corner myself by choosing this, the small enclosure, so if I had a bigger enclosure, that would have been easier to deal with, right? But look, I think we can fit this. I'm actually confident. So this is in. You must be also careful that I can't just put this all the way down because this is the uh, end of the enclosure, so I might not be able to fit this. Again, I can do all sorts of things like bend the leads, etc. But like, whoops. And you probably noticed we haven't put any, uh, not a single line yet between the pins. Especially, this is quite common, I think, at least when I do this, because we have lots of constraints when it comes to in terms of boards, so it's kind of a very tricky to get that, you know, right straight away. Look at that. And to move it, no, it did not work. I can distribute align to vertical center. No, it doesn't work. It works for these, for components, not for text, really. Um, it's we're gonna see what we're gonna do with that. So we don't have too many options, like we have to fit them in the space that we have, so that's how it's going to work, to be honest. There's nothing in terms of is this good, bad, whatever. Yeah, it my rule of thumb is like keep in and out pins as far as possible, just so there's no crosstalk and there's no feedback because this is high gain circuit. But other than that, your mileage may vary. If you think you're getting a bit noise or something, you need to maybe revisit the design and do things. But most of the time, you know, like for pedals, should be okay as long as we don't do something crazy like route things all the way around and make a big antenna and then we pick up all sorts of things. But we are in the enclosure, so that helps. But again, you know, just I think we gotta keep the all the connections as close as short as possible, you know. Okay, so these are four. I can see that this is connected there, this one is connected there, that one is connected there. Where is this one connected? Oh, down in here. So I move this there. And to move this with cursors, okay. Yeah, this is going to be tight. So you press Control, you can so select and press Control. What's going on? Shift, sorry. Control is to. I forgot. Damn it. Shift and you click on them. You group them so you can move them like this. So now we're gonna fit this, but oh man. You know what? I can move this whole. Yeah, I can do that. I can do that. Good for me. Yeah. Okay, we have it here. Wow. I need to see how this looks on 3D view. Whew. That's tight, huh? But it will work. Keeping in mind that if you don't put pots here, we use wires for them, we get more space. Okay. Let's try to wire things up. Huh? What'd you say? Uh, let's do that. All right, so we will be using two layer boards. So we have two copper layers, right? Front and back. There's absolutely no rule what goes front, what goes back. This is just convenience. So, you know, we can route our traces. We can route them on both ends. Um, what, because we're not really dealing with digital traces. Digital traces could be uh, thin, for example, for TTL level, or they might need specific requirements in length, impedance matching, whatever. We don't need to worry about most of that. For us, this is analog signal mostly, and what we need to just do is we'll have a slightly wider traces than what you get in digital, and try to keep them as short as possible. Now, some of them are not really carrying any signal, like for LED, so that doesn't really matter. Uh, Power traces don't really matter. We should have them wider just to, wider the trace, lesser impedance resistance, but that might introduce a bit more stray capacitance, etc. But like, um, let's start connecting things finally. Okay. So what you do is you have it here, selected trace, selected layer, and then we need to click route tracks, click there, and just this is our in, and this is tiny. So let me undo this. What this does, it takes width base of net class. I had it predefined before. I don't know. I might need to with my template. I might be trying to do something about that to give myself more options. But like here, let's do the thickest one in that there, and let's try to make it pretty. This is okay. We can always add this predefined. We won't be really using most of these widths. I'm just gonna remove them, even though they're there, and then you can play with it. These are predefined here in design rules. Maybe I shouldn't be doing this, huh? I think you can always add whichever width you want. But these are some kind of a standard values coming from that came with the template. So we're gonna keep this 0.762 millimeters. That's, what is this, 30 mils? I think. Let's keep on doing this. So for these ones, we could even do a bit wider. We'll talk about ground in a bit. Let me see if I can just do something real quick. Things are getting a bit messy. Program will try to keep this, to route it the best way it can. This is too wide to go between these pins here. We'll sort it out later. This one here. Okay, this one is going to be a bit. Okay. And we'll use both of these layers, so they should be pretty okay. We just try to we don't keep them parallel for too long for crosstalk, but everything else should be, I think, okay. But that's just what I follow. General generally that's how I do it. Okay, ground. We should probably do ground one of the first ones, and there's an option to do copper pour, and we do copper pour. The benefit of that is it's way easier. Sometimes it is helping with signal integrity, etc. Sometimes it helps with noise, sometimes it doesn't. People don't like it or like it. I don't know. I think it's good to have, but we'll keep it simple here without that ground pour. So these are power lines, 9 volts. How do I know? If you zoom in, you might be able to see it. KiCad puts you what is the net name. Here, these are just, if I press escape and select it. Okay, you select this pin and it will show here net. And this one is random. It goes from D1 cathode net. Yeah, just random. The ones that we didn't name, but these ones that are named, you know, plus 9 volts. And this one is out. Ground, for example. Let's keep on doing this. Okay, we're gonna go and change layers here. It's going to be a bit tricky because I see here there's ground on this side. Let me just rotate this. Okay. You'll have trouble doing that, you know, otherwise. Let me, so you can change the layer. So let's get it back to, so let me connect ground here. So this is going to be our main entry point for ground. This is going to go directly from our power. So this is one point where all they should connect. We shouldn't have any loops or anything, you know. So just keeping that in mind. That's the main thing with this. Okay. So let me change the layer. I do try to keep everything in one layer, but this board is so tight that, you know, it's going to be a bit, it's going to be impossible to do it without, you know, using both layers. This should be okay. 9 volts. Yeah, they're kind of a parallel, but that should be okay because this is just power bearing still, you know, there is some kind of a, you can always get some noise in power supply, but we should be okay here. Um, the main thing is to keep this output is going to be, yeah, it's not going to be that huge of a signal. Again, if you remember that LT spice, it was 0.2 volts on the output or something like that. Okay. Mm. So if you're going for absolute, I don't know what your, what do you do? In some cases, you know, if we get some noise, we might need to completely reroute this. But the thing is, like, as I said, cornering myself into this position with choosing the um, well, I cornered myself choosing this format, so that's going to be a bit of a tricky one, right? Well, that's not good. So you will end up in a situation like this that it's going to get a bit tricky. Okay, here. So we have ground here. This is okay. You can connect from here if you want to. And you can see here there it is, these lines are showing what needs to be connected. So this is going pretty okay. Try to keep these, okay, but you can always undo. Okay. No particular, I don't know. I just like how this looks like better rather than this making a huge difference. I don't think it would. Let's connect this one more. Oh, what did I do? Like, oh, because my wires are my tracer too thick to go through here. So we have 9 volts here, and that's going to be a bit tricky one to get. And it's not a big deal, even if you do it this way. Now, if I had a bit more time, I would have probably, well, if I wasn't doing this directly on video, I might have done something a bit more, bit better, maybe, or no, not. I wouldn't say better. It just like moved it around. The problem is that uh, you will end up in a situation, or you always end up in a situation where some of things are not movable. So we have to put these pots here because that's the only way they can fit into the pedal. So that's pretty much given. LED, you can play with that. You can put it to the side or in the middle, or you could put it even, yeah, you can put it here, but because it has to go out up here. So we don't even need to have LED here. We can wire it directly to the switch. That's also an option. So let me just run here DRC, and let's see what we get. So we have 9 errors. No, well, we have 120 violations, but 9 errors. Okay, so let's see what that means. We don't really. The main first thing that we need to deal with is this unconnected item. Okay, and that's not good. Okay, so we need to wire that up, but you see how this goes all the way around. So this is going to be a bit tricky one. And if you wanted to do this, you could play around with this a bit more. You could try to change the wiring. We can do vias, vias, or I don't know how you say that. But like, let's see what we can do with this. How can I could get it on top copper here, and then make this line smaller here. I could do VS here. Mm. Let's see if we can reorder these. resistors, and that's what we're going to do. So if I move this up here, this one there, that one there, keep this at the bottom. Yeah, that will work. Okay. So first of all, I'm gonna click here, press U to highlight the whole trace. I'm gonna delete it. So now I can move it to the side. I'm gonna press it, click here, press U. Same here, U, delete, U, delete. So if you press right click, let's see if I can find how to highlight the whole trace, you know. Select, you see select expand connection. So you can do that as well, you know, that way. You can move it. You delete, move. It's a bit annoying, it snapped into place. And now this will be okay. Let me see, 3D view. Again, don't rely 100% on 3D view, you know. Because now I'm pretty confident this will fit. I've done this before, but let me see here if I shift click these four, right click, and you can actually align and distribute them, you know. And we say distribute vertically, and you get a pretty decent, you get them spaced evenly based on the first and the last in the selection, or top and bottom in this case. Okay, so let's continue wiring up. Let's see if this is going to work this time around. Wait, I did it like this last time, right? Didn't I? Okay. Here. Done. This one was here. This is brilliant. See how when you click here, it highlights all the traces, right? So I should be able to first of all get this one here, and then there. That doesn't look half bad, huh? Took us a bit, but unconnected items, 0. We have 133 violations, so this is going to be a bit okay. We need to go through and check all of them, unfortunately. And there's no really way around it. Lots of them are going to be, you know, we need to deal with errors first and foremost. So this one is, for example, saying that footprint R5 and footprint D1, their courtyards overlap. Okay. And if you remember what I said here, it's like, let me hide everything here. I'm just gonna hide everything except the courtyard. So you can see that this courtyard overlaps. What the program doesn't know, we're gonna just bend up this LED, and it won't overlap. So that one we can say exclude this violation. Okay, so we have one less, but this is a bit time consuming. We have to go through all of this now, and you can see that all these little arrows, they're all highlighted here. So for example, we can go and I know exactly what these are here. I should be able to say I click here, and this silk screen is clipped by the edge of the board, and we don't really care about this. So what I'm going to do is I'm going to ignore all silk screen clipped by board edge violations, and all of a sudden we have only 108. Okay, not a huge improvement, but you see, like, I know it's clipped here. I could move it up there. I should probably, because this might end up, and yeah, let me do that. No, you have to be careful here. Unlike in schematic, these don't move because, you know, like, it can't just guess what you want to do. But conceptually, if they're linked, you know, in the what you call it, on schematic, it doesn't really matter. But here it does matter how you want to link it, you know. But I didn't need to do this. Now I realize this. So let me. So you can highlight this. I think Cage, is it? No. Oops, what did I do? Uh-oh. Okay. I keep forgetting how do you do this. You can highlight the whole network, all the pins. But here, I can just delete here. For example, connect it here. Would that make any difference? Would it make it? Could have I done that before without all this? That's a good question. Yeah, it's like, I think I'll just keep it. Let's see, we have error here. Courtyard overlap, again, footprint J2. Oh yeah, this is our out. Okay, is overlapping with this. Yeah, we can ignore that. So this courtyard overlaps. Yeah, this is for pots. You know, H1 and footprint R2. This is not entirely true. However, when we put that plastic tab through here, that might be hitting into R2. Well, we'll take a risk in this case. Yeah, these two resistors, they will fit. We can exclude that. So I'm going to cover all errors, you know, so all 4 errors. R5 and H1, again, that will fit, no problem, that one. H1, yeah, it will be fine. We are soldering wire here, so this should be okay. Because what I did, I checked the bottom part is 7 millimeters, so it's something around here. It won't go all the way to here and interfere with our soldering. So we can exclude this. We can exclude that. That's two resistors, and these two. Okay. Whew. So we have 100 more to go. Now, lots of it silk screen will clip by solder mask. Where's that? Yeah, so silk screen is going over these pads, so we just need to move it. I'm just gonna rotate it and put it like this. And that should, let's see if that saves us. I'm gonna rerun it, and then let's see how many do we have. Do we have less? We have 97 just by moving that. Okay, so, and it is telling me now that it's probably overlapping here. Yeah, so now silk screen is overlapping. This is going to be a pain to get rid of, but like, let us exclude this violation, okay? What's this here? Ah, damn it. And I double click and it goes away, so which is a bit of pain. So we're having this silk screen overlap. Oh, this is power, is it? Okay, let's rotate. Oh, this is tight. Maybe if I move this as well, just to make it. I have more, right? Yeah, because now these are overlapping here. And I wish I could. And they should move that text along this grid. So the moment we are using this, I don't, yeah, that's the grid we're using. And I try to make text be at a different, let's see, maybe it's graphics. I don't know. No, that just does not work. Which is a pain. What I can do is I can always change the grid here, I think. And you see how more control we have. Okay, so let's do that. Now there's always this trade-off between, quickly positioning it and because obviously if it is a bigger grid, it's easier to uh, trace it. Just move C1 here. So let me move these designators. They will be then easier to, they won't be overlapping that much. So you see this Q2 is overlapping a lot here. Whoops, not that. Let's put it here. Where's the other Q? Oh, Q1 is here. Now you still want to be able to see it and put it in the right place, so 99, 67. The reason for this is that this is using lots of, I think, semicircles or something. So that causes a lot of that overlap. If I put it here, also I want to be unambiguous which one is which, because you want that. 67, okay, we're flying through this, right? C3, I'll put it here. Maybe not great, but look, out, put it here. Let's put in here. Okay, let's run this again. 35. Okay. There's a bunch of them here. There's some here. And most of the rest are, you see here, these markers. If I, yeah, silk screen overlap here. So we can ignore that one. These are, yeah, it's not great, but we are getting a bit. Okay, silk screen again. This one is here. And I think it shows one for this line and for a line for R2 and line for R4. So it's kind of complaining twice about them, you know. We're going to exclude this. You see, this is kind of doing it several times. I'd say it's probably this line and then that line and all combinations of them, you know. So I'd say we're just gonna. It's so annoying. It detects this as a double click, I'd say. Must be something with a new version. It's gone. So let's see. We have front silk screen overlap. Bottoms. Yeah, so you're gonna get this silk screen clipped by solder mask. So silk screen will be clipped here. So if you really care about this, you know. So, but what this means is that silk screen won't go over the pad, and we don't really care. And here it's going to be a gap here because it's, you know, this is a drill. So I think we can, all these silk screens, we can just ignore them, I think. Yeah, this is, yeah, we're just gonna ignore silk screen overlap. So what and it might give you a different, some difference here, like silk screen clearance and whatnot, but Fabhouse will just clip that silk screen a bit, and we can ignore it. Okay, so this is all for front silk screen, but this is for back silk screen. We can ignore that as well. That's it. So what we want to do is like make sure that this is going to be, we can make it. So C1, C4, that's clear. Q is underneath. C3. R's, I'm not really happy with them, but I really have nowhere to put those R's. In power, LED, RV1, RV2, that's kind of important. Yeah, but we'll be okay with that. So far so good. What I'm missing is my, and again it detects double clicks. Maybe my mouse is busted. Okay, let's see if I can slot this anywhere. There's no room anywhere. This is so packed that, you know, none of this is going to, I just won't be able to fit it anywhere. I'm gonna put it on the bottom. Yeah, not great, but look, we squeezed the logo there. And what we're gonna do is we're gonna do another front silk screen and we're gonna put some text. And I normally put the name and then I put some kind of a date. And this is now it's March 2024. This is my version of this. Let's put it, let's make it center aligned. And we can see it here. Maybe I can put it here so it's on the other side. No, I would say this is escape. This is kind of important to have because at some stage you simply won't know when did you make this. You kind of okay, I did this now. I might not be happy with performance of this, or I might, I don't know. So I might need to revisit this, you know. And I just noticed here, this one really should be behind this capacitor. Okay. All right. I don't think it mattered, but like sometimes it does matter, especially if you're doing these filter caps. Uh, I think this is it. It's quite fast, quite quick on this. Maybe I could have done a better job. The thing is, you don't really care if it sounds well, if you don't have too much interference, etc. Things that we did not cover here. First, the first thing I'm going to do is I'm going to print this out and cut it out and fit it into Enclosure and to make sure that it fits. And this is kind of an important part. Okay, so it's very easy to print this. You print, tell it what layers to include. I really care about edge cuts. I'll put silk screen and front copper just for my just to make sure that I can actually see what's happening with that, to kind of orient myself. Okay, it's A4. I use A4. If you use something else, just set it up and print. Print 1:1 always, because that gives you the um, real kind of a exact size, I suppose. Let's see. And after printing, whew, I cut it out. That was narrow miss. Okay, so as you can see here, there's like 1 millimeter. It's off. Now this is quite big. Like, well, it's not quite big, but you wouldn't be able to fit this into Enclosure. So luckily, I printed this. So this is where I'm just kind of need to drive this point back. Like, it is super important to check every time, whatever you do, check every step. So let me, this is measurement tool, 34.9. Okay. So when I was looking at that, I was like, 34.9. But inside is 33.7. How the hell did I get this wrong? Okay, so I misread this most likely. So let me do something about that. So I'm just gonna move this. So I'm gonna press N. That I find that the easiest. Move it. Press Enter. I'm gonna use this one. We have some leeway. By the way, you saw how tiny that board is, huh? So I'm gonna select here. And because I didn't move it up and down, I can just move just the end of the edge. And you see it tells me when it snapped into place. Click here, the same thing. The same thing. Save it. Measure it again. 34.5. I need a bit more. So I'm just gonna move it here, M, and maybe 2, 3. Oh, I forgot to change the. I changed the what you call it. I changed the grid. That's why so it's moving in such small increments. And now we have to be careful because there is a clearance at the end of the board that we need to respect. So we'll see how far we can go with this. Again, measure 34. I still need at least half mil. Okay, so I need to be careful about this though, because if I move it more, these pots may not fit. Actually, speaking of pots, I need to check if I can actually fit them side by side. So occasionally just look at the 3D viewer. Okay, this is going to be tight. I need to zoom out. So I hope I don't need to redo the whole video again from start because I messed up the whole board. But let's see. I'll be double checking this all around, you know. It's 34, 3. Oh man. Okay. We move this up to here. I'm not sure if I can move this. So let's do this. I'm gonna just move this to the side. I have some room here. Not ideal, but look. I'm gonna delete this. This is getting out a bit here. So let me move this. I'm gonna delete this one. Move this. And if you think you can get it right first time around, that's great. Most of the time, it's not how it works. It's good to strive for it, to get it right first time around. But sometimes things they just don't work that way. And we live and we adjust. So yeah. Now I need to move this. And now we're getting a bit tight with this R5, I believe. Okay. And this is okay. We can move it a bit. Again, we're okay here. You delete this. Okay, so I move these things, and I just need to keep connecting. I just don't like this. Okay, here, there. And what we do is we run. This is too close here, I'd say. rewire that. Okay. Let's run DRC courtiers overlap because we moved this. I need to ignore this again. We have no unconnected ones, so this is good. Exclude this violation. Courtiers overlap. I know this should be good. Exclude J4 and this should be good. Again, 7. You know what? I keep saying this should be good. Like I don't really check this, so center. And this is like thereabouts. So and definitely not good here. Oh man. Okay. So this is okay here, but here, this one is a bit tricky one. As I said, like it's 3.5 millimeters is the base here. So this is going to get in the way of this one because you see this is 3.8 plus the hole, so we need to do something about that. And we just put it here. Now we need to rewire this. You get the drill. Let me remove silk screen from the view. It's just distraction. I'm gonna delete this. We'll see what we're gonna do there. I might move it here and then rewire everything. Thank God I practiced this, right? Okay, this is not too bad here. This is 9 volts, so this is okay. I can do it this way. That's okay. Move. It's like there's nowhere to put it. I should be able to fit it like here. Oh man. All right, that should be it. That should be it. Now, of course, I still haven't fixed that. And to move, we can get it here. And for whatever reason, my mouse started doing double clicks today. This is tight. Okay. Now, the snapping into place, so it's a bit of a tricky one. The question is this going to fit into enclosure? These pots now. Yeah, they should fit. I don't see anything. Right, turn around, you see. I don't see the body of the up until here. So that should be okay. Okay. Ideally, you put pots, you put it through the cutout of the board, see if it fits. It's better than ordering it and it doesn't fit. You Yeah, I squeezed it in somehow, didn't I? Okay, this needs to go on the bottom layer. No. Oh, things are getting a bit. Okay, this one is not that critical. We can go around here because this is that LED minus, right? So it just turns on the LED. So that's it. So the last one to finish, I think. And this is all okay. So these ones are not critical. So and I wouldn't be too worried if some things look a bit ugly. They should be okay. Um, we're do we go now? Okay, so print, cut, test whether it's going to fit. This time I'm gonna punch through my two pots and see if they can actually fit in the enclosure. Let's do that. Okay, after checking, let's see. So it is fitting. Now you have to be careful, it has to be perfectly straight. It just moved a bit when I was taking the photo. It fits, there's enough wiggle room there. This is going to be incredibly tight though. And look at this. So two pots, they are barely fitting next to each other. And this needs to go to the left half a mil or so. The pins are slightly bent, so don't be fooled by this, but you can see that this is incredibly tight build. And you have to be careful, and you have to be careful with scissors all the time, but in this particular case, try to cut it straight as much as you can, or you might get incorrect results. So let's see once more 3D view. So the only advice I can give you, don't use 15B, 1590A, use B, has more room. You'll probably be happier. This is so tight, and I'm gonna move it to the left. Again, more work. So move, that's it. 3D view again. That's really it. Now I have to just double check this track. I'm gonna delete this. I'm gonna delete that. I'm gonna delete that. I'm just gonna rewire that real quick. And this. Okay, let's do this real quick. And this. And this, and oh, wrong one. DRC 8 hours courtyard, we know this. Okay, exclude R5 and H1. Yeah, we made it, so it is going to fit, right? So this is okay. So this is actually okay here with the pot, because this one tab is going to go that much. Anyway, it's just mostly because of the soldering here. Okay, this is okay. Exclude this. Again, this is messing me up. Maybe I'm pressing this wrong place. So pots, we know they're gonna fit. Fingers crossed. So H1 and C2, again, we covered that. Yeah, this is going to fit. And we will have to be very precise once. So all of this is okay. So this is it. We are done. Okay. One of these days I'll learn how to navigate this. Oh. So 1590A, pain in the back. But it wouldn't be this interesting if it was easier than this. Okay, so that's it. What I'm going to do now, I'm going to uh, order this. Let me close all of this. Okay, so here what I have is, if we wanted to now send this to pub house, we would need to, we can do this, you know, like fabrication outputs, we can create Gerber files, and we can do all sorts of things. It gets a bit tricky, you know, you need to know all these parameters, whatnot. There's an easier way, okay? So the easiest way is to go to plugin content manager, and here you can find plugin probably for your fab house, okay? As you can see, there are a few there. I'm using PCB, so I'm just going to install that. You click install, it's pending, apply, and let's see, this is first time I'm using it at version 8. So what this does is, when you open your board, you see there is a new button here, and it just pop out on my different window. So I'm logged in. Make sure that you're logged in, and here it is. So it detected that it's your PCB. You can see the price here. You can see the shipping. Shipping is Ireland. In my case, anyway. And you can do, you know, you see the various. I'm just gonna keep it like that for now. Single pieces, you can go and read what this is, you know. Here you can do panel by customer, whether you create panels by PCB weight. Some of the fab houses don't do this. Like we're gonna go single pieces, because everything was done for us. We get this all pre-populated quantities by default 5. That's $5 plus shipping. This is, I think, all standards. I want to make sure that I have everything here covered. I always go for lead free. That's for no, there's no difference in price. It's a pity that this one is quite a bit more expensive, but lots of times they upgrade it by default, but like makes no difference for us really. That's pretty much it, I think. And you can see, like, the only thing I changed was I did this lead free here. That's it. Save to cart. I have no parts. There's no illegal of, well, I hope nobody finds this, any of this offensive. What the heck? Okay, no. I hope you're not going to use a fuzz face as a weapon of mass destruction. Maybe mass excitement? I don't know. Yeah. So that's it. I'll reach out to them and get them to send me this. So that's pretty much it. You know, you can then complete your order, do whatever you want. There is a little review there with the PCB. You can see the details here. Order status subject to audit. I don't know why. Maybe they want to audit cool stuff. And this is the first time I'm saying that it's subject to audit. So what's going to happen is I'm going to get email when it was reviewed, and then I can proceed with ordering it. So what we covered a lot. I think this is like more than 3 hours video. We'll see when I finally get it completed. I'll know how long this they took. Forever. Took me several days to just even record and do all of this, and you saw I still had to do something on the fly, make amendments, check stuff. So it takes time. Bill of material took me a while. Needed to get all the ones sorted out. That I did that more than a month ago, but I just didn't have time to sort this out. Only now I saw that this is going to be a bit crap. D1 here. Okay, look. I can cancel the previous order and but this what happens, I kind of rush to finish the video, so I should have probably moved this here, you know, C4 here, but remember I turned off this. I made all of this to ignore. I'm ignoring all of these silk screen overlap. So just kind of I can't get now this D1 to show, so I can just hide stuff around. And maybe I can get it. D1, so I can move this D1. Or reference, I can. Okay. So, you know, I probably won't bother at this stage. I just want to get this ordered. But the biggest piece of advice is take your time. We're not in a rush unless you're recording a video like me. We covered a lot. We covered how to, first of all, use template to get you started. I always use, I never start from scratch. How to draw the whole schematic. We talked about how input, output, things are getting a bit different because this is conceptual diagram. So when the rubber hits the road, proverbial rubber, you have to maybe make adjustments to your diagram. That shouldn't be the case because it's kind of it's conceptual diagram, but reality is slightly different. But we covered all of this, you know, we did all of that, and then we even covered the bill of material there, right? And I'm gonna share this tiny bit. We looked into data sheets for lots of these lots of these elements, you know. Eventually we got to and I'm clicking around and where's my stuff? Eventually we managed to squeeze everything on this tiny board, and I hope you saw the photos that it's really tiny. I'm actually a bit scared how tiny it is, but everything will fit eventually and we'll make it work. What I'm going to do in the end, I'm going to put on my website all the index of everything that I covered here, so you can just click and go to that part if you don't want to review the whole thing, and if you don't want to, I'm totally with you. The last bit, and we'll finish this. Maybe wait for my next video when I get the boards, assemble them, make sure that it works and it doesn't sound like crap, and we go from there. Okay? Until then,